Precast reinforced concrete flat slab bridges accounts for 1/3 of the roughly 9,000 bridges in South Carolina. Most of these bridges were built decades ago and have exceeded their original lifespan. They were designed for much smaller trucks than what we use today. Both of these factors have led the bridges to become load posted, which affects both travel and commerce, all at the cost of the public. SCDOT contracted the University of South Carolina and Clemson University to investigate the strength of precast slab bridges and to create efficient and cost-effective methods for strengthening the existing bridges in hopes of decreasing the amount of load postings.
First, we work with the SCDOT to find precast slab specimens that used to be a part of actual South Carolina bridges. In this way, our lab specimens and tests closely match the real conditions. Our labs have hydraulic jacks and frames that can simulate the load of trucks driving over the specimens. We tested 12 of them just as they arrived at the lab without any modifications. The unmodified specimens provide the baseline or the control measurements that we needed to compare with the modified tests. Additionally, we learned many of the slabs are much stronger than the theory would suggest. With this information, SCDOT can remove many of the load restrictions that you see on bridges around the state.
Other bridges need to be strengthened before the load restriction can be removed. And this brings us to the second part of the project, which was designing and testing different strengthening methods. We looked at the inventory of all the precast slab bridges and determined that if we could create methods that strengthen these bridges by around 20%, then we could have solutions for most of these bridges around the state. We investigated 4 different strategies. Strategy 1 was to bolt steel plates to the bottom of the slabs as reinforcement. Strategy 2 was similar, but instead of steel plates, we used carbon fiber attached to the bottom of the slabs. Strategy 3, we were working from the top of the bridge, and we bolted steel plates and channels to the top as reinforcement. The fourth strategy was to connect back-to-back slabs together. By joining the slabs into a continuous structure, different parts of the bridge help each other to carry the truckloads. We tried each of these strategies in the lab, and each of them can be used to meet the target strengthening goal of 20%. By creating different strategies, we give SCDOT options they can use depending on the specific circumstances of a bridge. For example, carbon fiber can be used in locations in the low country where salt water is present and rust is a big concern. Or if a bridge is getting new pavement, the plates and channels can be bolted to the top of the structure before the new pavement is installed. Our goal was to give SCDOT a box of different tools so they could choose the right one for the job. It's rare that I get the opportunity to work on a project with such a huge impact. Of all the projects I've worked on, this is the one I'm most proud of.
USC and Clemson were able to create knowledge that helps approximately 1,100 bridges around the state. The research team is continuing field trials of these strengthening methods in research project SPR 758. Soon, they will have similar information about pre-stressed channel girder bridges, which make up a decent portion of the state's inventory. We are looking forward to seeing the positive impact of these projects because each one of these bridges is important to the economy, safety, and livability of South Carolinians.